Hello children, welcome to channel Sube. Children, today I am going to discuss question number 49 from the MCQ part of 2021 Physics New Syllabus paper. The figure shows a vertical cross section of a conical flask filled with water. The height of the water level in the flask is 0.25 meter and its circular base has a internal diameter of 0.20 meter. The diameter is given at the bottom. The volume of water in the flask is 2.5 times 10 power minus 3 cubic meter. So volume is given. What is the magnitude of the total force exerted by the water on the inclined surface of the flask? Density of water is given 10 power 3. Take 5 equals 3. 10, 20, 30, 40, 50. So children, I remember we had the same type of question in 1987. You see, it is given using the symbols, not the numbers, values. So those days we didn't have English medium papers, English medium exams, even English medium classes, A-level classes, only Sinhala medium and Tamil medium. So I have the Sinhala medium paper. So you can understand the H is given, rho is given, the height H is given, rho density is given, cross-sectional area is given, but instead of that in this question they have given the diameter. So you see in 1987 the same type of question has been given. So therefore some people say that if you do past papers for 5 years back is enough, but according to this question you see 5 years is not enough. You have to do as much as past papers even in 1987. Without any practice you can't solve this problem at the real time examination time. So you should have a practice. So therefore you better try those very old past papers even. So children, let us try to solve this problem. So children, you have to consider the water, mass of water and the flask separately. You have to consider the equilibrium of these two bodies. Therefore I delete this flask. I delete this flask like this. Only water, the volume of water I take into account. Then I draw the flask some distance away so that I can mark all these forces. So like this, the flask I draw some distance away so that I have room here in between the flask and water to mark the forces. To mark the forces. So this one is the flask. So this part we don't want. So first of all let us focus, pay our attention to the mg, that is the gravitational force, the weight, mg. So mg is there. Mg equals, we know, V sigma g. V is the volume. Volume is given 2.5 times 10 power minus 3 cubic meter. Then density is given 10 power 3, so G is 10. So we get these people cancel. So 25 Newton, that is the mg. So I delete this one and I write 25 Newton. Just I write 25, we don't want the Newton story. So that is the force. To keep this amount of water without dropping, we have to give opposite force equal to 25 Newton. Otherwise we can't keep this amount of water without dropping. So who is giving this force? This force is giving, to balance this 25 Newton, the flask. The flask must give that 25 Newton however. So let us check the amount of force that is given by the flask. So to do that, you have to consider the pressure here. The water pressure here is pressure P, pressure we can calculate using H rho g. So H is given 0.25 meter. Density is given 10 power 3. So G is 10. Then altogether 4 zeros, therefore 2500 Pascal or Newton per square meter. That is the pressure. So due to pressure, you know pressure equals F divided by A. So there is a force. Force equals pressure times cross sectional area. Not cross sectional area, the area, the total area of this bottom, because the force is acting on this bottom. Because we took the pressure at the bottom, this one is the bottom. So in the water, very close to the bottom, glass bottom, we have taken the pressure. So pressure is 2500, then times area is 5 r squared. So 5 they have given as 3, r is, the diameter is 0.2, then half of it 0.1, 0.1 means 10 power minus 1, so the square is minus 2, 10 power minus 2, so 2 zeros cancel, 25 times 3, 75. 75 Newton is the thrust given by water. It is given by water, therefore I mark it using the same color, blue color. So water is blue, so imagine like that. So there is a force, so that is a thrust given by the water towards the glass bottom, only to the bottom. So what is the amount? 75. I take this bottom a little bit downwards because I have another force to mark. So that is the force given by the water. So now according to Newton's third law, so this one is the action in blue color, that is the action. So there is a reaction from the bottom towards water, uh, 75 equal to this one, 75 Newton. Upwards, 75 Newton. So from the bottom to the water, amount of water, there is a force equal to 75 Newton. So that is too much. We need only 25 Newton upwards, but there is a force equal to 75 Newton already given by the bottom. So to cancel, there must be some cancellation, 50, only we need 25. So to cancel 50, what happens? From this side inclined surface, a force is given to the water. So before calculating that, let us again consider, focus our mind to the force that is given by the water, as we did here. First we focused our mind to the force that is given by the water, and the reaction then thereafter we considered. So first of all, you should understand that there is a force like this given by the water towards the inclined surface. So to understand that, imagine that there is a hole like this on the inclined surface. Then what happens? If there is a hole like this, suppose this one is a plastic bottle, plastic flask, then we can make a hole. So what happens? If there is a hole, the water jumps out like this. You can imagine that water jumps out like this. So that means definitely there is a force given by the water to this wall. So now we are going to calculate that. Not calculate, actually we are going to consider that. So there is a force like this. So if there is a force like this given by the water to the wall, inclined wall, so there is a component towards this way, and also there is a force, that force must be perpendicular to the surface, because that force is created by the pressure. So there is a certain pressure at these points. Even at these points there is a certain pressure. The pressure gradually increases when you go down like this. It is decreased when we go up like this. But however, there is a certain amount of pressure. So due to that pressure, there must be a force. If there is a pressure, there must be a force. So that force is definitely perpendicular to the surface, like this. So here also there is a force. You can accept it, because I explained that there must be a force. If there is a hole here, the water jumps out. Why water jumps out like that? There is a force already the water is giving to the inclined surface. So the surface is not, when the surface is not there, what happens? The water jumps out. Like imagine that there is a certain board, a person is pushing it like this, and suddenly this board break. Then what happens? This man is thrown towards to the front. So the same way the water jumps out from the inclined wall if there is a hole. So now you can believe that there must be a force acting on the inclined surface by the water. So there are components towards this horizontal like this. So these forces do what? If the flask is made of rubber or something like that, it can inflate like that. It will increase its volume due to this force, but it can't happen because the glass is not a flexible one. So therefore these two forces cancel each other. It doesn't do anything. These two components cancel each other. And there is a component also this way, vertically upwards like this. There are two components, we know. So then we can't draw this one, because now we have considered both the components. The horizontal one cancel each other. The vertical component is still existing in this system. So that force must be able to cancel 50 Newton from this 75. So now let us consider, say this one is F, this one is say F dash, totally around. So I can't say two forces because there are infinite number of forces around this, because this area is a circular one. So there is a amount of F dash, say. So so action and reaction again. So due to this action, this one is the action, it is acting on the glass wall. So from the glass wall, the reaction is equal to that amount F dash, vertically downwards like this. There is a force equal to F dash. So this one I should write using blue color. So there is a force F dash by water, by the water. So same amount of force acting on as a reaction, action and reaction. Reaction is always opposite. So therefore downwards F dash amount of force is given by the inclined surface to the water. So now we can delete this force, because now we have considered the force given by the glass, given by, not that one, this one. And also now we don't want these forces. We know there are, we are considering only the reaction, reaction and the mg only, reaction and mg only. Remember that if there is a block on a surface, we consider mg, and what else? We consider the reaction. Reaction is r. Those are the only forces we consider. So like that, the same way we consider the downwards force, that is only 25 Newton, blue color, 25 Newton. So that must be balanced by the glass, that must be balanced by the glass. So glass gives 75 upwards and there are 25 downwards. So to balance this part of the inclined part of the glass must give, to cancel 50 from the 75, 50, this F dash should be in red color, this F dash should be 50 Newton downwards. Then what happens? Totally the glass gives 25 upwards, because 75 is given upwards from the bottom, and from the side surfaces 50 is given downwards. So 50 is given downwards, 75 is given upwards from the bottom, that is. But we need to balance the amount of water. So water gives 25. Water gives 25. So to balance it, now this 50 must be there. This 50 must be there. Then 50. Then from this 75, the resultant of this one, resultant of this forces given by the glass is 25 only, 25 upwards. So that is the resultant given by the glass alone. So the water gives 25, that is the mg. So they are equal and opposite. So that is the equilibrium state. So it can achieve the equilibrium state without dropping. 25 is there downwards and 25 is there upwards. Even though there is 75 from the bottom, opposite there is a 50 by the glass, to cancel 50 from this 75, and the remaining value is 25. So like that, now we know finally the inclined glass surface gives to the water 50. What they ask is magnitude of the total force exerted by the water on the inclined surface. So what they ask is, what is the force given by the water? So what we deleted, this one, is what they ask. So that should be equal to this 50. So therefore now we can mark this one is 50. So equal to that, the glass gives another 50 downwards, but opposite to this one. So however, the water gives upwards 50, must be 50. So that is what they ask, force exerted by the water on the inclined surface. So they ask this one. So we can say this one is the answer. They don't ask the direction. The direction is this way. In that past paper, they ask the direction even. So this one is horizontal, this one is upwards, this one horizontal, the direction, this one downwards, this one again upwards, this one downwards. So they have asked the direction even, but here they don't ask the direction, only the magnitude they ask. So this one is the answer, children. I think the way I explained is good. I think you are happy. Let us check the answer. Question number 49, fifth one, says fifth one. So we have obtained the correct answer. So children, if you are happy, what you have to do, subscribe my channel only if you haven't still subscribed. If you have already subscribed, don't press that button again, then it will be cancelled. And what else you can do, share my link among your friends so that I get a bigger audience. So I am helping you, so you can help me that way. And also you can press the bell icon so that the benefit of that is to you. And also you can press thumb up, give me a like, that means, so I will be very happy to see likes. So children, I am helping you, so you are helping me, so we can do this for a long time until you sit for the exam. So children, then see you tomorrow at 6 o'clock in the evening. Goodbye.